Okay everyone, hello! In today's video, we're going to thoroughly explain one of the hottest topics in the IT industry right now, AWS's Graviton. If you watch this video, you'll understand everything about Graviton, so please stick around until the end. First off, we'll start by talking about what exactly Graviton is and why it's getting so much attention right now, just the overview. Graviton, well, this is an Arm-based processor that Amazon Web Services, or AWS as it's commonly known, developed in-house. It's emerged as a completely new alternative to the x86 architecture CPUs that were mainstream in traditional data centers, and it's bringing about a major transformation in the world of cloud computing. In recent years, the demand for cloud computing has exploded, and the requirements for CPUs have become more sophisticated, right? In particular, the balance between cost efficiency, power saving, and performance has become extremely important. Graviton is, like, a CPU that AWS developed by bringing together its many years of experience and technology to meet these very demands. Its high potential is attracting a lot of attention both inside and outside the industry, Furthermore, the evolution of the ARM architecture itself and the resulting expansion of its adoption in data centers are also major factors increasing the attention on Graviton. In this video, we'll cover everything from the basics of the ARM architecture to the background of AWS developing Graviton, its technical features, advantages and disadvantages, specific use cases, and even future prospects. By the time you finish watching this video, you should get a sense of how Graviton is going to change the future of cloud computing. So without further ado, let's jump into the world of Graviton. If you found this video even a little bit helpful, please give it a thumbs up and subscribe to the channel. We're also waiting for your thoughts and questions in the comments section. Okay, next, let's take a look at the basic knowledge of the ARM architecture. ARM, which stands for Advanced RISC Machines, is a processor architecture developed by ARM Holdings in the UK. Originally, it was rooted in a RISC-based processor developed by a company called Acorn Computers, and due to its high power-saving performance, it has been widely adopted, mainly in mobile devices. Yet many of the devices we use every day, like smartphones, tablets, and embedded devices, have ARM processors in them. So, what exactly is the RISC architecture? RISC, which stands for Reduced Instruction Set Computer, is an architecture that aims for efficient processing by simplifying the instruction set. There's also the contrasting architecture, CISC, or Complex Instruction Set Computer, which has a more complex instruction set and is good at multifunctional processing. RISC is characterized by its simple instructions, which make circuit design easier and provide excellent power-saving performance. To give you an analogy, CISC is like a multifunctional Swiss Army knife, while RISC is like a simple and easy-to-use kitchen knife. The main strengths of the ARM architecture include, first of all, its power-saving capabilities. Due to the characteristics of the RISC architecture, it consumes less power and is ideal for battery-powered mobile devices. Next is cost efficiency. Its simple design makes it possible to reduce manufacturing costs. Furthermore, its flexibility is also attractive. It's easy to customize for various uses. On the other hand, a weakness of ARM is software compatibility. Compared to the x86 architecture, software compatibility can be lower. Especially for server applications, many are optimized for x86, and porting to ARM may be necessary. Also, while it was previously said to be inferior to x86 in terms of high-performance processing capabilities, this gap is narrowing in recent years with the emergence of ARM Neoverse and such. The ARM architecture, which has been mainly used in mobile devices, has also been entering the server market in recent years. This is because ARM's power saving and cost efficiency are expected to contribute to reducing operating costs in data centers. Furthermore, with the emergence of high-performance cores like ARM Neoverse, processing capabilities for servers have also improved significantly. Okay, next let's look at the background and purpose of AWS developing Graviton. There are several factors behind AWS developing its own CPU, Graviton. First, with the expansion of demand for cloud computing, the requirements for CPUs have diversified, and there was a need for CPUs that were more optimized for specific workloads. Also, there was a desire to build a more cost-efficient and power-saving cloud infrastructure by developing their own CPU, as they felt there were issues with the price and power efficiency of existing x86 CPUs. In developing Graviton, AWS set clear goals. Those goals were to achieve performance equal to or better than x86 CPUs in specific workloads, reduce server operating costs, and provide services to customers at lower prices, and improve power-saving performance to reduce environmental impact. To achieve these goals, AWS designed its own custom silicon based on the Arm Neoverse core. Graviton has had multiple generations so far. The first generation Graviton was the first Arm-based processor developed by AWS, based on the A72 core, and it supported basic workloads. Graviton 2 is based on the Neoverse N1 core and has significantly improved performance compared to the first generation Graviton. In particular, floating point operations and memory performance have been enhanced, making it compatible with a wider range of workloads. Graviton 3 is based on the Neoverse V1 core and has further improved performance. It can now handle advanced workloads such as machine learning, HPC, and high-performance computing. And the latest Graviton 4 uses an even higher performance core, achieving further performance improvements and power savings. AWS provides EC2 instances equipped with Graviton processors. These instances are more cost-effective and power-saving compared to x86-based instances and are used for various workloads. Graviton instances are used in a wide range of fields such as web applications, containerized workloads, databases, and machine learning, and are an important element supporting AWS's cloud services. Okay, next let's take a closer look at the technical features of Graviton. Graviton processors use the Neoverse series, which are high-performance cores for servers developed by Arm. Neoverse cores balance high-performance processing capabilities with power-saving performance, making them ideal for use in data centers. In particular, from Graviton 2 onwards, the latest cores such as Neoverse N1 and V1 have been adopted, resulting in significant performance improvements. AWS designs its own custom silicon while still basing it on the Arm core. This allows them to develop CPUs optimized for AWS's cloud services, achieving higher performance and efficiency. Custom silicon design is one of AWS's strengths and is an important factor in enhancing Graviton's competitiveness. Graviton processors also focus on optimizing memory and I/O. By implementing high-speed memory interfaces and efficient data transfer mechanisms, they maximize the processing power of the CPU. This allows them to achieve high performance even in memory-intensive workloads and I/O-intensive workloads. Furthermore, Graviton processors are also equipped with hardware-level security features. This protects the system from unauthorized access and malware attacks, enhancing security in the cloud environment. For example, they have implemented features such as accelerated encryption processing and secure boot functionality. Okay, from here on, let's look at the advantages and disadvantages of Graviton. Graviton processors have been reported to perform at the same level or better than x86 CPUs in specific workloads. In particular, Graviton 2 and Graviton 3 have shown excellent performance in web applications and containerized workloads. However, software optimized for x86 may require porting to Arm. Graviton instances are more cost-effective compared to x86 instances. Especially in long-term operations, they can significantly reduce TCO, or total cost of ownership. This is due to the power-saving performance of Graviton processors and AWS's cost optimization efforts. Graviton processors are characterized by their low power consumption due to the characteristics of the ARM architecture. This can reduce power consumption in data centers and reduce environmental impact. Also, reducing power consumption leads to reducing operating costs. On the other hand, a challenge with the ARM architecture is software compatibility. Software optimized for x86 may not work directly in the ARM environment. Therefore, you need to use software compatible with ARM or port the software to the ARM environment. AWS is working to solve this issue by providing tools and services to support software porting to ARM. There are a few things to keep in mind when using Graviton. First, you need to check if your existing software is compatible with ARM. Next, migrating from an x86 environment to an ARM environment requires some work. And to maximize the performance of Graviton, software optimization may be necessary. Okay, next, let's look at specific use cases of Graviton. Graviton instances are ideal for hosting web applications. Their high performance and cost efficiency allow you to both speed up your website and reduce operating costs. Also, Graviton is suitable for running containerized web applications and is highly compatible with container technologies such as Docker and Kubernetes. Containerized workloads can greatly benefit from Graviton instances. Graviton's power-saving performance and high performance enable efficient container operation. Also, container technology makes it easier to port applications between different architectures, so migrating from x86 to ARM can be done smoothly. Graviton instances are also used for database operations. Especially for scale-out databases, Graviton's cost efficiency and high performance are effective. However, depending on the type of database, optimization for ARM may be necessary. Graviton instances are also used for machine learning inference. Graviton 3 is equipped with hardware accelerators specialized for machine learning, which can speed up inference processing. Also, Graviton's high cost efficiency helps reduce the cost of machine learning inference. Furthermore, Graviton 3 is also used in the field of HPC, or high-performance computing. Graviton 3's high-performance cores and high-speed memory interfaces can handle advanced workloads, such as scientific and technical calculations and simulations. Many companies and projects are adopting Graviton instances and enjoying their benefits. For example, companies that provide web services are improving performance while reducing operating costs by migrating to Graviton instances. Also, organizations that are conducting machine learning research and development are accelerating the speed of research and development by using Graviton 3 to speed up inference processing. Okay, now for the final section. Let's look at the future prospects of Graviton. AWS has stated that it will continue to invest in the development of Graviton processors. It is expected that they will continue to develop higher performance Graviton processors and lead the evolution of cloud computing. Also, to promote the adoption of Graviton, they will focus on software optimization and expanding tools and services for developers. The ARM ecosystem is increasing its presence in the server market with the emergence of Graviton. As the number of ARM-based servers increases in the future, it is expected that software developers and vendors will also move to support ARM. This will further expand the ARM ecosystem, and the use of Graviton will also spread further. The ARM architecture will play an important role in cloud computing. Its power saving and cost efficiency can reduce the operating costs of cloud infrastructure and reduce environmental impact. Also, with the emergence of high-performance ARM cores, more workloads will be able to run on ARM. It is expected that Graviton processors will continue to innovate and evolve in the future. Various technological innovations are expected, such as the adoption of higher performance cores and the implementation of new hardware accelerators. Also, AWS will provide new services and features to promote the use of Graviton. Finally, let's reaffirm the importance of Graviton. Graviton is an ARM-based processor developed by AWS and is bringing about a major transformation in the world of cloud computing. It has an excellent balance of power saving, cost efficiency, and performance, and is used for various workloads. The emergence of Graviton has the potential to greatly change the future of cloud computing. I hope this video has deepened your understanding of Graviton. Graviton can not only contribute to reducing the cost of cloud computing and reducing environmental impact, but also has the potential to create new business opportunities. Please consider using Graviton and maximize its potential. That's all for this video. Thank you for watching until the end. If you found this video even a little bit helpful, please give it a thumbs up and subscribe to the channel. We're also waiting for your thoughts and questions in the comments section. Well then, see you in the next video. Goodbye.